From San Francisco's Golden Gate Bridge, you throw a heavy rock upwards with an initial speed of 2 meters per second. How far does the rock fall in 3 seconds? We start by pulling out of the problem the relevant information we've been given. It's a heavy rock. That means we can ignore air resistance. Thrown upwards with an initial speed of 2 meters per second. The initial velocity is plus 2 meters per second. We are defining up to be positive, the usual convention, and therefore the initial velocity has a plus sign. We are on the Earth. San Francisco is a city on the planet Earth. Therefore the acceleration is the acceleration due to gravity, negative 9.8 meters per second squared. The time is 3 seconds. We are being asked to find delta x. We can now use our equation. Delta x equals v naught delta t plus 1/2 a delta t squared. And we have an initial velocity. We have an acceleration that's not zero, so we have to use the full-blown equation. 2.0 meters per second times 3.0 seconds plus 1/2 times negative 9.8 meters per second squared times 3.0 seconds squared. Seconds cancel the seconds here. The seconds squared here, I have a typo. This was meters per second squared. So we have seconds inside the parentheses here, but that's being squared. That cancels this second squared. So we now have 6.0 meters plus negative 44 meters, 44.1 that I'm rounding to 2 sig figs. So we end up with negative 38 meters. It's 38 meters below where we released it. An interesting follow-up question is, how fast is it moving at that moment? We're going to use our delta v is equal to acceleration times delta time equation. Our acceleration, negative 9.8 meters per second squared times 3.0 seconds gives us negative 29.4 meters per second, or to 2 sig figs, negative 29 meters per second. That's our change in velocity. Our actual velocity at that moment is equal to the initial velocity plus the change. So our initial velocity was plus 2 meters per second, and we're adding to that a change of negative 29 meters per second. So our final result is 3 seconds after being thrown upwards at 2 meters per second, the ball very quickly came to a stop and is now falling downwards 38 meters below where it started and downwards at a speed of 27 meters per second.